Good morning, students. We are discussing the chapter motion, and last class we studied the various terms which is related to motion, and today we are going to start the graph, how we can represent the motion by a graph. How we can represent motion by a graph. There are two types of graph: distance time graph and velocity time graph. Distance time graph and velocity time graph. There are two types of graph: distance time graph and velocity time graph. The graphical representation of motion. Usually we are using the line graph to represent the motion. You might have studied what is graph in maths, and how we can represent the slope and all, the linear and what is straight line, all the things you might have studied in maths. And the last year you have studied that how you can represent the motion in your 7th standard always. Especially in 7th standard you might have studied how we can represent a graph of a motion. So this is just a continuation of that. So we are using line graph to represent distance time and velocity. By distance time graph we will get the speed. You know that distance divided by time, it is nothing but speed. Where the equation for speed, it is distance time, distance divided by time. So it gives the speed of the object. And velocity time graph is usually we are using for the representation of acceleration. So these are the two main graphs that you have to study today. We are going to discuss today distance time graph and velocity time graph, the graphical representation of motion. Graphical representation of motion. Let us see the first one, distance time graph. You know that you are familiar with the graph, and it has two axes. First one, this is x-axis and this is y-axis. And the independent value we are using x-axis, and dependent values we are using y-axis. This is time, the independent value which is time, and this is we are using distance time graph. So time we will give in x-axis and distance we will give on y-axis, distance. Let us give the unit. Time we are using seconds and distance we are using meter. So definitely speed is equal to meter per second. The unit of time we are using here is second, and unit of distance that we are using meter. So definitely we will get speed is equal to distance we divide by time with the unit meter per second. First of all, let's give the values: 5, 10, 15, 20, etc. And here 10, 20, 30, etc. The interval here we are using the interval 5, 5, 5, 5, and here 10, 10, 10. Suppose an object, it is moving from here 0 point, and its first 5 seconds, it covers 10 meter. It covers 10 meter. Then the point, we can give the point here, and its next 5, that is 10 seconds, it reaches at 20 meter. reaches at 20 meter. The next 15 second it reaches at 30 meter. Suppose one object is moving initially, which was in rest, and from there it started. After 5 seconds it reached at 10 meter, and then next 10 it reaches at 20, and next it reaches at 30. And suppose if you are giving a line here, definitely we will get a straight line. We will get a straight line. We have taking here intervals, equal intervals of time. This is equal distance covered by the object. First of all, it was in 0 meter, means at rest, and after that it started. First 5 minutes is covered 5 seconds. 5 seconds it covers 10 meter. Its first 5 seconds it reaches at 10 meter, and next 5 seconds it reaches at 20 meter, and next 5 seconds reaches at 30. Means here the intervals are 5 and here also 10. It means it is uniform speed. It is in uniform speed. The object is moving in uniform speed. Here the 5 seconds interval of time, and it covers 10 meters. Then we can say that it is uniform speed. The object is in uniform speed. Equal distance in equal interval of time. So always we can say that the distance time graph of a uniform speed of an object which is in uniform speed always gives a straight line. A straight line always gives a straight line. The distance time graph of a uniform speed, an object which is moving in uniform speed, gives straight line. It gives a straight line. And now let's see how we can calculate the speed by this graph. How we can calculate the speed by this graph. Here we are just taking the slope and see. Suppose we are using first of all, for finding that, you should select any 2 points from the straight line. Any 2 points. You can select any 2 points. We can select here and here, or these two, whatever is up to you. We can select any 2 points from the graph, and after that we want to give a lines, or we want to join that points to these 2 axes. I'll explain. Suppose I am selecting these 2 points. I am selecting these 2 points. Suppose randomly we are selecting. Randomly you can select. There is no rule to select. We can select from this straight line 2 points. That's enough. And these 2 points I selected. I select these 2 points, and after that we have to join these 2 lines into x-axis and y-axis. X-axis and y-axis. And this also I am just joining this line to x-axis and this line to y-axis. I repeat, in this straight line you have to select any 2 points, and that 2 points you have to join to its corresponding x-axis and corresponding y-axis. and just see this one. This line, it is parallel to y-axis. These two lines parallel to y-axis, and these two lines also parallel, isn't it? This line also parallel to y-axis. It means you don't select a point like this. No, you don't join this point like this. You should draw the points perpendicularly to the x-axis, perpendicularly to the x-axis and perpendicular to the y-axis. This is a second step. So first step, first of all we have to select 2 points on this straight line. That is the first point or first step, and next one we have to join these 2 points to x-axis and y-axis. This x-axis, it is perpendicular to x-axis. It's very important. It is must be perpendicular to x-axis. This is the second step. And what is 3? This is time. So now we are getting 2 join points here, isn't it? These 2 points join here, and this also we are getting these 2 points. This is 10 second, 15 second, 20 second, 30 second. And this is time. This is time and this is distance. So we can give the time. I am just using the symbol small letter t for time. Small letter t, and here for distance I am just giving small letter s for distance. Small letter s for distance. And here this is T1 and T2. This is S1 and S2. This is T1 and T2, and this is S1 and S2. I am just giving the symbols. Simply I am just giving the symbol. First of all we selected 2 points, and we draw a perpendicular lines, and here also perpendicular lines to y-axis, and after that this joining points we are marking T1 and T2. Why? Because it is time on the x-axis. So we are marking T1 and T2, and here it is distance. So I am marking S1 and S2. This is S2 and this is S1. Okay, S1 and S2. And you know the equation, speed is equal to distance by time. Distance by time. Speed is equal to distance by time. And now we are going to find out the speed. So from here we have to select distance, and from here we have to select time. That is our intention. That is what we are going to do here. And now we have got 2 points here, isn't it? And now we can say, see here, this S1 and S2 and this T1 and T2. This space or this interval and this interval, now we are going to take. Okay. And for getting this interval, just first of all we can focus on this interval and see, this is T1 and T2. Just forget about these numbers, okay? I am just telling the general case. After that we will calculate the speed which you have given in the graph. Okay. So this is T1 and this is T1 and this is T2. For getting the time of this line, we are just finding out the difference between T2 and T1. T2 minus T1 means from 0 to 10. This is T1. isn't it? This is T1, that is 10 already here, and this is 0 to 15, this is T2. Okay, this is T1 and this is T2. So T2 minus T1 will give this line or this time interval. T2 minus T1 will give this time. And what about S distance? Let us see on y axis. This is S1. We have to get this one. Okay, we have to get this value, that is S2 minus S1. That is our intention. We have to find out S2 minus S1. That is these 2 points, the difference between these 2 points, S2 minus S1. What it is? What is S2? This is 0 to 30, that is 30, the S2. S2 is 30. And what is S1? It is 20. S1 is 20. So like that we will get the difference in distance in this interval and time. So what is distance now? S2 minus S1. S2 minus S1. So we can write S2 minus S1 and divided by time. What is time? T2 minus T1. T2 minus T1. T2 minus T1. This is time. So what is the speed that we are getting from this graph? The equation of the speed is S2 minus S1 all divided by T2 minus T1. S2 minus S1 all divided by T2 minus T1. And here from this graph, what is the value? See, this is 15 T2. Okay, let us take from first of all, let us see in the numerator it is S2 minus S1. And what is S2? This is 30. The point it is 30. And what is S1? 20. So we can write 30 minus 20 all divided by, what is T2? T2 is 15 and T1 it is 10. So 15 minus 10 is equal to 10 minus 5 is equal to 2 meter per second. Don't forget to write unit. It is very important. Okay. So this is 30 minus 20, 10, 15 minus 10, 5. 10 minus 5 is equal to 2. Equation distance by time and the unit it is meter per second. So we will get 2 meter per second. So we can say in this graph, in this distance time graph of uniform speed, it is the graph of uniform speed. Uniform speed. It gives us the speed of the object. So it always keep 2 meter per second of speed. It always keep 2 meter per second of speed. Let me repeat once more. What was our first step? First step it is, first step, select 2 points on the straight line. We are just trying to find out the speed. First of all, we have to select 2 points on the graph, and after that we join these 2 lines here which is perpendicular to the x-axis, that we got T2 and T1. Simply we are given the symbol. Okay, T2 and T1. And here S2 and S1. Simply we are given the symbol. And what is distance? S2 minus S1. What is time? T2 minus T1. So what is speed? Distance by time. So it is S2 minus S1 divided by T2 minus T1. On this graph, this particular graph, we got 2 meter per second. While we are using this equation, we got 2 meter per second. And next is non-uniform speed. Just say, look at the board. We are giving This is distance, then this is time. Some values are here. So at 0 second the object was in 0 distance, it does not move, means it is at rest. And after that, how we can give, first of all, how we can denote it? So here it is 0 0, this time 0 and distance also 0. Then after that 5 seconds, 5 seconds it covered 5 meter, 5 seconds it covered 5 meters, so might be here 5 seconds it covered 5 meter. The next 10 seconds it reaches at 12 meter, 10 seconds it reaches at 12 meter here. The next 15 seconds it reaches at 25 meter, 15 seconds it reaches at 25 meter. And 20 seconds it reaches at 29, the value 29. So it will approximately, it will be here, it will be here. See the graph, what it gives. First of all, 0 second it was at 0, and 5 second 5 meter cover, 10 second 12, 15 second 25, and 20 seconds 30. So what will be its graph? Let's see. Will you get a straight line? No, you won't get a straight line. So this is, we studied it is, what it is? This is non-uniform speed, non-uniform speed, the object which is moving non-uniformly, So this is about distance time graph of uniform speed and non-uniform speed, uniform speed and non-uniform speed. In the case of uniform speed, the graph gives a straight line, but in non-uniform speed there should be a linear variation. We won't get a straight line. So this is the difference between uniform motion or uniform speed and non-uniform speed, the graph between distance time, the graph which represents speed. Next is velocity time graph. As usual, as in the previous case, we are using x-axis and y-axis. Here 0 and this is 5, 10, 15. This is time, yes, second, and this is velocity, 10, 30, 40 gives, and this is velocity. Unit, what is the unit of velocity? Meter per second. Unit of velocity is meter per second. Don't forget to use the unit. Wherever you are using the variables, you should give the unit, or else the values will change. Okay. So we are using, now we are studying velocity time graph. The time independent value and velocity dependent value, which we are giving on y-axis. The time and the velocity. See, suppose we are using an interval, and here see the velocity is, suppose the velocity is not changing, then suppose always it gives 30 meter per second velocity. Suppose first of it when it reaches at at 5 seconds it was on 30, and 10 seconds say again it keeps the same velocity, and 15 seconds again it keeps same velocity. Suppose an object is moving in same velocity or uniform velocity. Uniform velocity. I will explain once more. Look at the board. First is 5 seconds. It speed is, what is meant by velocity? Don't forget, it is speed with direction. Okay, speed with direction. So first 5 seconds, you are just by using the speedometer in your vehicle, you are seeing that the object, that car or bike, whatever, that vehicle, the speed of the vehicle, it is 30 meter per second. After 5 seconds, again it shows 30 meter per second. Again it shows 30 meter per second. And in after next 5 minutes, that is 15 seconds. After 5 seconds, 15 seconds, again it shows 30 meter per second. What it means? It is mean a uniform velocity. It is uniform velocity. Means velocity is not changing. Velocity is not changing. It always keep a constant velocity, we can say. It keep always a constant velocity. And for this motion, so uniform motion and uniform velocity, the velocity time graph gives a straight line which is parallel to x-axis. Why it is shows like that? The speed in the speedometer does not change. Does not vary the value. So always keep 30 meter per second. It's the same speed. Suppose you are using or you are moving in a car with this same speed, just moving in a straight line, same speed. Just imagine 30 meter per second while we are showing in that speedometer. It shows velocity 30 meter per second. So we can say it will be a straight line. It is also a straight line, but which is parallel to the x-axis. If we are taking the value of time here. Okay. And now, how we will get the distance from this velocity time graph? How we will get distance? What will be the distance? Distance is, suppose we are as I told you in your case, suppose you are making using any two points and making a straight line or joining these 2 points to x-axis. Suppose selecting 2 points and joining line to x-axis. Y-axis we can't. So this area gives the distance. We can say that it is nothing but an area of a rectangle, isn't it? This is a rectangle. This is area of a rectangle. And suppose we are giving this is A, B, C, D. Then the area of the rectangle ABCD gives the distance. Area of rectangle ABCD will give the distance. I repeat. First of all, we draw the velocity time graph, and after that we just use 2 lines and we make a perpendicular line, or we just join this line to x-axis, and then we got a rectangular area. The area of rectangle ABCD. So the area of rectangle give distance. Area of rectangle will give the distance. What's area of a rectangle? What is a rectangle? It is in a rectangle. Both sides are equal, not four sides. If it is four sides, it is square. But here, these opposite sides are equal. So we can say it is rectangle. So I am just taking the rectangle, area of rectangle ABCD. Area of rectangle, area of ABCD. ABCD will give the distance. What is the area of rectangle? What is the equation for that? It is side into side for a square. In a rectangle, it is length into breadth. Length into breadth. For a rectangle, the area is length into breadth. Length into breadth. What is length? This is its length, isn't it? This is length. Or we can say AB into then AD. AB into AD. AB into AD. Area of ABCD is equal to length into breadth is equal to AB into AD. It gives AB into AD. Then what is AB? That is AB. AB is equal to, see here it is, this is time. Okay, this is a difference. So this is T1 and this is T2. As I told you, this is T1 and T2. So what is AB? This AB, this is AB is equal to DC is equal to T2 minus T1. This interval, this time, T2 minus T1. I repeat, first of all we have to get this AB, the value of AB. It is AB is equal to DC, isn't it? This length and this length are same. Why? Because it is a rectangle. So opposite sides are equal. So this is AB is equal to, this is DC. DC, what is DC? T2 minus T1. T2 minus T1, this difference. So it is T2 minus T1 into, what is AD? AD, this is 30. Okay, 0 to 30. Why? Because it is constant value, velocity, constant velocity. So this is equal to, T2 minus T1 into 30. So we can write 30 T2 minus T1 unit. Area of ABCD will gives the distance. It will gives the graph, it will give the distance. So it is meter. So this is the value of distance from this graph. Velocity time graph. Okay. The next, what is the velocity time graph for a accelerated body? What will be the velocity time graph for an accelerated body? You study there are two types of acceleration, uniform and non-uniform. So first one, uniform acceleration. Let us see. You have two columns, you can see here velocity and time, and this is seconds. The time we are using seconds as the unit, and for velocity kilometer per hour. Simply we are using kilometer per hour. And see, this is 0 and 0, this value 5 second 9 kilometer per hour, and 10 second 18 kilometer per hour, and 15 second 27 kilometer per hour. Means the velocity is velocity is increasing uniformly. Here it is 9 and then 9, then 9. That is 9 minus here 0 to 9, 9, 9 to 18, 9, 18 to 27, also 9. Uniformly increasing. Let us see the graph. First of all, it is 0, then 5, it reaches at 9, and for 10, it reaches at 18. Reaches at 18. Then next 15, it reaches at 27 approximately here. So definitely the graph will give another straight line. For uniform acceleration, the graph again will give another straight line. Then what will be the distance? Distance, now we are going to find out the distance again from this graph. What will be the distance? We studied it is nothing but this area, means while we are using 2 points from this straight line, first of all we have to use 2 points and a perpendicular line both sides, and this will give the this area will give the distance. Suppose we are giving this is A, B, C, D. A, B, C, D. To get this distance of this area, we are just splitting this area into 2. Simply we are just splitting it into 2. So now we are getting, this is a rectangle and this is a triangle. This is rectangle and this is triangle. And suppose I am giving this symbol E here. This point it is E. So A, B, E, D is a rectangle and B, C, E is a triangle. It is a triangle. So what is the area? It is distance. The area is, total area will give the distance. What is total area? Area of rectangle plus area of triangle. Distance is equal to total area. Area is equal to area of rectangle plus area of triangle. Area of rectangle A, B, E, D. A, B, E, D plus area of A, B, E, D plus area of B, E, C. Area of B, E, C. And here, what is area of A, B, E, D? It is, since it is a rectangle, it is length into breadth. So A, B into B, E. A, B into B, E plus area of B, E, C. Area of B, E, C. Area of B, E, C. B, E, C is a triangle. So what is the area of triangle? Half into B, E into EC. Okay, half into BE into EC. This will give the distance of for a uniform acceleration. Okay. Then what about non-uniform acceleration? Non-uniform acceleration won't give this type of straight line, as we told in the case of non-uniform motion. It won't give this type of straight line. It will vary linearly. Okay, so this is about today's class. There are what we studied today: 2 types of graph: velocity time graph and distance time graph. First of all, we discuss the distance time graph, and next velocity time graph. So this is graphical representation of motion. Okay, so today class is over, and I will, as usual, I will send the homeworks and activity on your Google Classroom. Okay children, thank you.